Today I'll be doing LeetCode 104, maximum depth of binary tree. This is an easy question, but if you can't solve it, I wouldn't be discouraged. It is one of the first few questions you'll come across for trees, and this is kind of like the learning basis, so I wouldn't be discouraged if you didn't get it. It is hard to wrap your head around, obviously, but it lays down the foundations for what you will be doing with the rest of the questions. Now, I'll get to the question now. What does maximum depth actually mean, right? So maximum depth, you could basically say, is the maximum number of nodes along a single path, or you could say essentially 1, 2, 3, 4. So the maximum depth of this tree would be 4, because we can go up until level 4, right? There's still an 8 here, up until level 4, and that would be the maximum depth of the binary tree. Or you could consider basically the number of nodes in the longest path. So the path would be 1, 2, 4, and 8. And remember, a path is from root to leaf, right? In this situation. Now, what is the thought process behind this question, right? Some people might start from the very top and think about solving it, right? But what you want to do is actually the opposite. There's two ways to solve this, obviously. There's BFS and DFS. I'll be explaining the DFS more because that is the more standard approach, and I guess this would take you a lot more thinking compared to BFS. I've done the BFS level order yesterday. You can literally just change a bit of the code and it will work out the same. But DFS now. Okay, DFS. What do we do with the DFS, right? DFS usually requires recursion, first off. And what do we want to recurse on? So the first thing, when you ask 8 about its children, right? Do you have any children? Does 8 have any children? No. But it has itself, right? So we will just put 1 here, okay? So then the number of children it has is 0, but it has itself 1. Then we'll ask the same question to 4. Do you have a left child 4? Yes, you do. Do you have a right child? No, you don't. So you will just add yourself and the one that you have. So you'll get 2 here. Then you'll come to node number 2, right? And you will ask your left child, can you give me the value you have? So 2, right? And then I will ask the right child what value you have. 5. Now the way 5 got 1, it's the same way that 8 got, it's 1. It's just itself. It has no children. Then 2 will see, okay, the deepest one, the one that goes further down the tree, is the one that's coming from 4, right? Because it has a higher number here. So it will take the 2. It won't take the 1. It will take the 2 and it will add itself. So it will become 3 now. And we'll do the same with 1. So on the right side, 3 would get 1 from here, 1 from here. It wouldn't have to choose. It wouldn't have to bother choosing because it's going to be 1 either way. It will add itself and it will get a 2. Now 1 will do a comparison. It will check between 3 and 2, get the maximum and add itself. Now, and the answer that comes out of top 4 is conveniently the depth, basically the maximum depth, right? It is just conveniently the answer. So it's essentially just that. You basically ask, just how farther deep does the tree go from the current node that I'm standing on, and I'll add 1 to it, right? I'll ask my child, my left or my right child, how deep do you go? And whichever one is the deepest, I'll pick that and I'll add 1 to it, and then I'll return to my parent so that my parent can add itself. Then the parent will go to the root and the root will add itself, and eventually you end up with the maximum depth. right? Now the solution for this is pretty elegant. If not root, that's obviously going to be our base case, right? Because we will be hitting null values if given. Now if not root, return 0, right? We have nothing. There's nothing to ask the node. You won't even get a 1 because the node doesn't exist. So if not root, return 0. Then we'll ask our left. Now how do we ask our left? We ask our left by calling the same function on it. Now I'll show you the dry run of this code so that you understand it a bit better, but for now I'll just write it out. So we'll ask our own left for like the value, then we'll do the same for our right. We'll ask it for the value. And simply after that, what we want to do is return 1 plus the maximum of left and right, kind of like what we did at node number 1, right? We asked our left, we asked our right, got the maximum, added 1, same for 2, right? So now what do I mean by these two statements, right? It seems a bit unintuitive. Why do I have that? Now this boils down to how recursion works, right? This is just something you're going to have to practice, right? This will come this doesn't come naturally. This is only after you do a couple of questions that you understand this. It's kind of like your factorials and your Fibonacci recursive sequences, right? If you haven't looked into those, definitely look into those before attempting more recursive questions. These are like the very basic questions. Now what do I mean by ask your left, ask your right? So let's consider a run through. So when we do 1, if we do 1, let's consider the left, so that will call 2, right? Then let's consider the left of 2. Sorry, I'll write this out as left here, write this out as right here. We'll just not bother about the right now because the more important one is the left, right? So roots left, we get 2, right on the right is 3. We got node number 2. Now we'll ask the left over here, we get 4, and the right over here is 5. Luckily 4 also has a left, so we'll consider that. And now we're stuck at 8. Okay, at this point you can just consider the thing has ended, because even if it does call the function again, it will call it on null, and we already have that set to 0, so it doesn't matter, right? Now at level 8, what does left return for 8, node number 8? Left will say 0 because there's nothing. Right will say 0 because there's nothing. Remember, it's null, right? It's null. Null. So left will say nothing, right will say nothing. But what will the function return in that case? It will return 1 plus 0, 0, maximum of either one of those, right? 1 plus max of 0, 0, which is just 1, because the max doesn't really matter, right? That's what happened with 8. And now and you know what, something about stack is it behaves like something about function recursion is it behaves like a stack. So you can think of building like blocks, right? And every time you do something, so when you do left, okay, when you do left, you can think that 2 is stored here, 4 is stored here, and 8 is stored here. So the first one to get work done is the first thing on top of the stack, right? So we'll do 8's work first. Now that we've done 8 and we've gotten this return value of 1, we'll unwind this and we'll have 1 stored here, right? Now we'll do work on node number 4. So when we're on 4, we'll ask our left, right? 4 only has left, so we'll ask left, what value did you get? And what was the value we got for 8? We got 1, right? So we just say 1 and then right. Since it's not, it will just be 0, so it doesn't matter. And now again it will just return 1 plus 1, so 2. And we're done with 2. We're done with 4, so now we have 2 as the variable. Now we'll come to 2. The left will say, since left was 4, it will say 2, right, because that's what you got. Right, on the other hand, it will just be 1, right? I'm not going to show the entire process, but there's no children for 5, right? And it's only itself, so it will do the same thing as 8 did, right? Equal to 5. I'll just write it down, left and right, and it will just do return 1 plus what is greater than 2 or 1, 2, so we'll just do 3, right? And now we've managed to do 2 as well. We've stored our variable as 3, and we've managed to hit the root, right? Because in the frame we were just doing root.left, so now we're at the root. So now we've hit 1. We'll process 1. What do we get at 1? So if 1 asks its left, what are you? You're 3. Right, you came out to be 2. I'll simply just say return 1 plus 3, so 4. And that's literally it. Once we pop it off, we'll end with the answer 4, and that is the answer. So that's how the recursion works. Definitely, I would, if you could get in the first try, very good, but if you couldn't, right, I would suggest doing factorials Fibonacci first, right? Understand how recursion, stack frames, stuff like this is important to understand as the basis, and then you can venture off to stuff like maximum depth, invert the binary tree, and other questions for BFS, right? Same thing, it's in my previous video. Just do a DQ, so a cube with the root, and just put in the elements, run a loop for the length of the queue at that point, and then just do level plus equals to 1. That will give you the answer. Just look at my previous video if you want an answer with BFS.